Welcome to another unit in this methodology toolbox. This time I'm talking about the different measures of association and which measure to use when. What we can say on our selection of the most suitable measure, you always have to consider the scale level of both variables and then select the method based on the weakest of the two scale levels. Meaning, if we have one variable which is ordinal, one variable which is nominal, the weakest scale level would be nominal, so you can only use measures of association fitted for nominal data. If you have one which is ordinal, one which is metric, you can only use these methods which work for ordinal data. With those comments ahead, which measures are there? Well, we can start with the weakest level with nominal scale data. Here we have the Euler Coefficient. This only works with a 2-on-2 comparison. So a very simplistic contingency table. First variable, only two possible outcomes. Second variable, only two possible outcomes. A bit more sophisticated and the most general statistic usually used is the chi-squared statistic and the chi-squared test. However, the problem with chi-square is this can take values between 0 and infinity, at least theoretically. So it's pretty hard to interpret what is actually a strong, what is a weak relation. To account for this, you can either use the contingency coefficient or Cramer's V. Both their advantages, both their disadvantages. Cramer's V is a bit more comparable to what we know, for example, later with correlation coefficients regarding the strength of the relation. So I would always go with Cramer's V if you want to have also an idea how strong is the relation you just calculated. If you have a bit better scale level available, meaning if you have ordinal data, you can either use Spearman's rank correlation coefficient, which is simply ranking your data and then applying Pearson correlation, or you can calculate Kendall's tau. It's like two approaches, whereas from a calculation perspective, Spearman's approach is a little bit easier. And finally, if we have metric data, we can use the covariance. The covariance, similar to chi-squared, has the disadvantage this is not limited by any values, so this can take values between minus infinity and plus infinity. If you want to counter this, use Pearson's correlation coefficient. This, similar to Spearman's version, is limited to -1 and +1. That's actually my final comment in this regard. The contingency coefficient, or the corrected contingency coefficient, and Cramer's V, they're both between 0 and 1, because we do not have an orientation with nominal data. So here it's simply 0 and 1. 0 meaning very weak or nothing, no relation at all. 1 meaning a very strong relation. With ordinal data and metric data, we have an orientation. So in both, we get values between -1 and +1. Negative values meaning a negative orientation, low values with high values with high values. A positive coefficient meaning high values together with high values, low values together with low values. So -1 +1 is a very strong relation. 0 is no relation at all. And this then concludes my short session on measures of association. I hope you enjoyed this and see you soon.